So I'm Sean Ray. I'm the head of the solution architects for the ASEAN team here at Amazon Web Services. If you ask me too much information about the ASEAN countries, I only moved here 5 days ago, so I'm not your best source of information. What we're talking about today is mission-critical applications. So there are mission-critical applications that might come to mind straight away, things like spaceships, life support systems. They're generally not running in your data center. So what we're talking about here is actually those kind of systems, the business-critical ones that you have. Might be an ERP system, might be some kind of database if you're a real estate agent, might be credit card payment information if you're a bank. We're going to talk about moving those into the cloud, what kind of security, what kind of compliance you will need to actually do that. What you're going to learn. So we're going to walk through best practices for deploying business-critical applications. We're going to dive deep into fault-tolerant architectures. So how do you actually make something that might not be designed natively for the cloud, fail over nicely, replicate its data nicely? And the last one, I'm going to talk quite a bit about security and how you actually secure your VPC and secure your workloads so that you reduce your attack surface. So we're going to talk through a couple of customer examples. Banking, health and media. Just to talk about different, especially those particular ones, because health is regulated by HIPAA in most countries. Most FSIs actually have regulators in their home country, have data sovereignty concerns, have encryption concerns. And then media. Because media is so pervasive and a lot of it now is online, big newspapers, they're also like a huge target for attacks, things like DDoS, things like ransom attacks. So we're going to talk a bit about that. And then we're going to actually build out a critical workload in the slides, talk about networking and security, talk about audit and resilience. So why are customers running critical workloads on AWS? So the first one, Capital One, they were our reInvent keynote last year, 2015. The main part, so this case study is publicly available, aws.amazon.com/case-studies. You can go and see these. There's a key quote in here that I really like. We work closely with AWS to develop a security model which we believe allows us to operate more securely in the public cloud than we do in our own data centers. From Capital One CIO. Orion Health, they're a healthcare provider out of New Zealand. They write software that goes into things like hospitals in the US. Every single workload that they deal with is needs HIPAA compliance. And the last one is News UK. So News UK, James Saul actually talked about News UK earlier. So they actually picked up SAP Business Objects, SAP GRC, Oracle Enterprise Manager, meaty critical workloads and actually moved them into the cloud. They also talked a little bit about security. The AWS focus on overall security, the ability to isolate systems for the internet, and the ability to encrypt data with our own managed keys. So we're going to talk through that stuff. We're also going to talk about isolation from the internet. Yes, this is the big scary public cloud, but what does that actually mean? So the benefits of running mission critical workloads on AWS. First of all, the security. So we have 1 million customers on our platform. If we develop something for an enterprise like a bank, or some kind of security feature, and we roll that out to the platform, you get it for free. It rolls out to the global platform. You don't have to go and spin up a project. You don't have to get business analysts to write your requirements and then go and actually put it into your infrastructure. As we roll that out, you get those add-ons for free. Last year, we released over 500 features. 40% of those were security related, specifically targeting enterprise workloads and making sure that we can give you the kind of security controls that you need. We have multi-factor authentication. You heard from Gemalto before talking about Gemalto two-factor authentication. We have private subnets. You can build networks that are completely isolated from the internet. They don't have to have access to the internet. The other thing about AWS, if you've ever been to any security talks, is you'll see this slide. There's different variations of it in different colors. We look after the actual security of the cloud. We get it audited. We make it PCI compliant. We do SOC 1 and SOC 2 type compliance audits. We secure the endpoints, the APIs. We make sure that they're using TLS encryption. On top of that, you are responsible for the operating system, your customer content, your encryption. We can't encrypt your content for you. We don't know if it's important to you. We don't know whether it's privacy information. We don't know whether it's credit card data. So what we do is we harden our infrastructure and we get our infrastructure audited. And on top of that, we give you tools so that you can actually specify how critical your content is to you. You can put in the identity and access management you need. You can put in the encryption and the controls to segregate your content in different workloads. AWS Global Infrastructure. This is also a very common slide that you'll see. We have 12 regions that are currently live. We've also pre-announced some other ones, and we have 33 availability zones. Every single region has at least 2 public-facing availability zones. That means that you get 2 data centers to run your workloads into for things like resiliency and failover. We also have 54 edge locations. We have 2 products in there. We have Route 53 and we have CloudFront. One is a CDN, but you don't have to use it as a CDN. It will also transparently proxy through dynamic content if you want to use the edge locations as some kind of protection for DDoS. How an AZ is actually made up is a mesh. So we have our transit carriers, tier 1 telco providers, and then we actually have the AZs. An availability zone is a concept that we use at AWS. It's a logical data center. Think of it like a logical data center. It is actually made up of 1 or more physical data centers. In one of the regions in the US, in one AZ, it's made up of more than 6 data centers. Each one of the availability zones has tier 1 telcos. It has separate redundant power. It has separate floodplains everywhere except Singapore because the island isn't actually big enough to have redundant separate floodplains. The other thing that you'll notice if you've ever read the product description of S3 is that data is actually copied to 3 locations. So there are 2 publicly available AZs, but there are actually 3. We actually replicate all of your data to 3 locations. And a typical DC for Amazon has between 50,000 and 80,000 servers inside it. That's actually physical hosts. That's not virtual hosts on top of. And we build them that size for a particular reason. It's about blast radius. We've got some million customers running on us now. We have banks like Suncorp. We have people like Capital One. We have Netflix. If we built these huge data centers that had hundreds of thousands of servers in them and we had some kind of outage, we would wipe out all of those critical businesses. So we build them small, 50,000 to 80,000. That means that if, in an AZ like in US East where there's 6 data centers making up one of those AZs, we lose one of the AZs, it is highly likely that your application, if it is pushed between multiple AZs, will not actually be affected. Only some instances inside that AZ will actually be affected. So we do it so that we can contain the blast radius if there is a failure. The other reason to run critical workloads on us is around security and reliability. As I said before, every security thing that we roll out to the platform, you get for free. Think about things like Heartbleed, slow loris attacks, these types of things. We responded to Heartbleed within 24 hours and had our infrastructure patched. How long did it take you to patch your on-premise infrastructure for Heartbleed? Performance. Intel gave a talk this morning on this track about the different CPU types. We've got the new X1 pre-announced, 100 vCPUs and 2 terabytes of memory. Experience. We've been doing this for 10 years. We've experienced failure. We've experienced growth. We've released new services. We're very good at it. And the last one is the partner ecosystem. So we heard before from Challenger, who used a partner to move into the cloud. We heard before from Gemalto, who provides hardware security modules for doing things like hardware cryptography. We have 2,500 of them in the marketplace. You can go into that marketplace and spin up any of their products as a VM and actually use it inside your own VPCs. So what's a mission critical workload? If you're a startup and you've got 1 server and you've got 100 customers, it's probably that 1 server. If you're a bank, it's probably something very different. It's probably some COBOL monstrosity. I think banking still runs on COBOL pretty much everywhere in the world. So let's break it down into something easily we can remember. So the first thing is, it will generally be mission critical if it's holding sensitive data. Privacy information, credit card data, that type of stuff. There'll actually be a liability if you're breached. In a lot of countries around the world, there's privacy laws. If you lose someone's date of birth, address, that type of stuff, then you'll actually be in breach of the law. Next one is large-scale customer impact. So you might not be holding anything in particular, but you might be like a real estate listing website where agents and people come and actually buy houses or rent houses off you. You don't have any critical data, but if your website goes down, then that's your entire business. Resilience. If you're a partner or you're a managed service provider and you're hosting something on someone else's behalf and you accidentally delete their encryption keys or you accidentally delete their backup and they lose all their data. And the last one is the material impact. What is the real material impact of your business? I used to work in a business when I was an operations manager, and I remember someone coming up to me and going, all right, this is our most critical day of the year. You know, think about like Black Friday sales. So we're an exchange, so we're doing lots of transactions, and they said for every minute that we're down, every 60 seconds, we're going to lose £600,000. So if we had an outage on that, I had this thing in my mind about, oh my God, I've lost 600,000. Oh my God, I've lost 1.2 million. That's the kind of material impact that we're talking about with a mission critical workload. So the next one is, what can I actually run? So there are lots of off-the-shelf type products that people run mission critical workloads. Here's a snapshot of some of the things. We have case studies for most of these. These are what customers are running on us where they're vendor off-the-shelf type workloads that we deem critical. Okay. One of the people I used to work for, James Wilson, said to me, we were trying to replace one of these old COBOL Fortran type things that people use in banking. And he said, if your board of directors knows the name of one of your systems that you're trying to replace, you'll never replace it. Because that system is obviously so critical that it's got, the name of that system has gone up into board papers, has gone into finance, budget planning, has been such a problem for your company that people in the board actually know what it's called. And that was true. For the entire time we were there, we tried to replace this mission critical system and we couldn't. And they're the type of workloads that we're talking about here, those meaty things that run your business that are hard to move. So if you're a big enterprise, the first thing that you're going to think about is, well, normally I go to a supplier and I get a contract. And you do actually get a customer agreement with Amazon when you sign up, when you put your credit card over. But if you're an enterprise, you're used to getting a different thing than, I get my customer agreement as soon as I click up and open an account. So we will do enterprise agreements if you have specific regulations. For instance, if you're a finance company and you have regulatory requirements. Those kind of agreements also cover, and the customer agreement does things like data sovereignty. We're in Singapore. We have a region in Singapore. If you put data in the Singapore region, we will never move it. We will give you tools where you can move it around other regions if you want to, but we will never actually move it unless you tell us to. Liability and IP. Who owns what IP? The next thing is Direct Connect. So we've got lots of partners here today who can enable you on Direct Connect. It's the next step up from VPN. Anyone who's an enterprise who's running a critical workload is going to be looking at Direct Connect. It's a 1 gig or a 10 gig low latency connection into your data center. It uses BGP. It's also good for cost reduction. Any traffic that goes out of your Direct Connect is cheaper than anything that goes out your internet. And the last one is enterprise support. So you're not going to put your mission critical workload into Amazon and then have no support around it so that when your CIO rings you up at 2 o'clock in the morning and everything's fallen over, you can't actually call anyone. So enterprise support will give you a 15-minute response time from Amazon. It will give you proactive support. We will give you a technical account manager who will work with your account. They'll come in once a month and they'll go through all the incidents that have happened. They'll look at all the different tickets. They'll help you with support cases with our service teams. And lastly, you'll get infrastructure event management. So if you're having a day where you're cutting over your critical workload, maybe you're like a mobile phone provider and you're actually having a flash sale for the new iPhone 7 that's coming up. They're going to be days where you're going to stress your infrastructure and you're going to want to make sure that it works. So we will actually come in and we will do a architecture review of the architecture. We will also give you a support person on site so that you get effectively a 0-minute response time. The other thing about being an enterprise is you're not really going to let everyone run around with their corporate credit card and just start spinning up accounts in Amazon. You need to be able to control some of that. So we allow you to do master consolidated billing. That means that you can go and spin up a non-production account, a production account. You can assign account roles so that you don't have to give permissions to each of those separate accounts, and you can link them all back to the one master account. You'll also notice in my pictures here I have the two-factor authentication for Gemalto. You want to have two-factor authentication on your account if you're doing any kind of critical workload, especially the hardware-based token. The reason you want the hardware-based token is we do support software tokens, but if that person who has registered their phone leaves your organization and you don't have access to that phone to log into your root account anymore in Amazon, we can't prove that you're the owner. We can't unlock that account for you. We have to go through a legal process for you to actually get back into that account. So if you're an enterprise, you need to put a hardware token on top of your account. You need to go and lock it in a safe somewhere, and then you need to actually build admin users that can do everything so that you don't need to access that root account. We don't want to have to, go through some kind of legal thing to prove the ownership of your account so that we can give it back to you if someone walks out with their phone. The last nice thing about that is that you get one bill. If you're already coming down your Amazon journey, you've probably already got multiple accounts, and getting multiple bills when you have to raise purchase orders inside an enterprise is actually very painful. So we will give you one bill if you do it this way. All right, so we're talking about critical workloads. Why don't we build some and actually see what it looks like inside Amazon? Here's your customer data center. Here's your things in your customer data center, your workstations, your users, your servers. Now, I've obviously greatly simplified this. You've got big, meaty edges with IPSs and protection devices in them, and layer 7 firewalls and layer 4 firewalls and all the other things that you need. Then we have AWS. Inside AWS, we have a VPC. If you've been to any of the places today where they talk about networking, you would have seen some of these built out. If you came to the track earlier where Mark Statham actually got on the command line and built some of these out, you actually saw one built. The only thing you need to create a VPC is a CIDR block. We allow between -16 and -28. If you're a huge enterprise, don't go and create a -16 when you start off your first digital workload and then start piling your workloads into it. You've just wiped out 65,000 IP addresses. Because when you actually connect that back to on-premise with your customer gateway, your virtual private gateway and your VPN or your direct connect, we actually peer that back into your data center. If you have an IP clash, we can't do that. So make sure that you talk to networking. Make sure that you actually design it if you're going to move a lot of workloads over to AWS. You cannot change the CIDR block in a VPC. It is one of the immutable things that we have. So if you choose something that clashes with your on-premise, the only way to change it is basically delete the VPC and redeploy your workload. Something to get right. Like all networks, you can break our CIDR block down into subnets. On your on-premise and all the places that I have worked, there is these two big pair of production core firewalls, and every time I had to get a change through there, it was change management and putting in change control and going through the whole ITIL process, and then some network guy would get up at 6 a.m. and make the changes and make sure we didn't blow anything up. And off that core firewall, we would have 100-24 networks. And the reason that enterprises have 124 networks, which we used to call the 120-legged spider, in fact, a network guy I used to work for, I used to give him a bug bounty basically every time he got rid of one of those -24s. So kill a leg off the spider and you get a bonus. The reason that exists is because in corporate networks, when we first started out in networks, we couldn't actually put more than 200 hosts on a network before all the ARP traffic and all the broadcast traffic would basically wipe out the performance of the network. In Amazon, we obfuscate the layer 2 network. You don't have that issue. If you want to stick 16,000 hosts somewhere inside your VPC, then you can. You don't have to build out 100-24s and have 50 different DMZs and all types of things splitting up. Okay, so we deploy some applications. deploy them into our 10 subnet here. That's all good. When you deploy an instance into Amazon, it has to have a security group. It is mandatory. Security groups by default are deny all. They're also stateful, so they're a layer 4 stateful firewall around the instance. They are not at the subnet level. If we deploy a second application in, right now, with no security group, they won't be able to talk to anything. If we add the security group, 10.0.0.6 and 10.0.0.5 will be able to talk to each other. But 10.0.0.7 and 10.0.0.8 are still isolated. It's an important point that's different to your on-premise. If you have a whole bunch of servers that are sitting on the same subnet on a switch inside your environment, it is highly likely they won't have a firewall between them. All the applications in web or app or DMZ will be able to talk to each other. In Amazon, security groups provide horizontal and vertical protection. If 10.0.0.6 doesn't have a security rule that actually references 10.0.0.5, they cannot talk to each other even though they're sitting in the same security tier. We can build it out again. We can now make the back-end apps only talk to each other. We can add in some databases. If you've been to the database talk this morning with Blair, we have Oracle RDS, we have MySQL RDS, we have MariaDB, we have Microsoft SQL, and we also have Postgres. So we have a managed database service that will do things like patching for you, and also OS management. Everything needs a security group. Your database also has a security group. You can cut it off from the rest of your apps. You can build that 3-tier architecture you have inside your data center if you want to. I've put S3 in here because S3 is slightly different. S3 is a regional service. The difference between a regional service and the services we're talking about here, S3 is not deployed inside your VPC. You don't get your own private block storage. We don't deploy it in there for you. From a security point of view, it actually sits outside, and it's also why it has different control mechanisms. We also have replication. If you want to replicate data from your database over to a slave, you can do that. It also needs a security group. There's a common theme here. The other thing is, if you are actually using RDS, then we've got a tick box that you can do that for most flavors. So you don't have to set up replication. But if you do want to, you can actually run your databases on EC2. You can use things like Oracle DataGuard to actually replicate between them yourself. You can use things like SQL always-on data groups if you want to actually do that on EC2 because you've got special requirements that you can't use RDS for. So we put some instances in the second availability zone. So each availability zone is connected by low latency fiber. The latency between those two availability zones is only going to be a couple of milliseconds. That means you can do things like real-time replication, well, near real-time replication, between data centers. It means you can fail over between instances in different availability zones. If you add in an elastic load balancer, by default an elastic load balancer has network interfaces in availability zone 1 and availability zone 2. It will actually peer that traffic between 10.0.0.6.5 and 10.1.0.6 and 10.1.0.5 if you wanted to. You get reliability and resiliency built out of the box. We can do some other things. We have EC2 auto recovery. If you have one of those type of off-the-shelf applications, or it might be an older application that's still running in your environment, that actually requires the IP address not to change, or requires the MAC address not to change, then we can use auto recovery to rebuild that box in place with the same metadata so that your application will actually keep working. So if we detect a hardware failure, we'll rebuild it with the same. If you put it in something like an auto-scale group, or you actually build it and you terminate it and you rebuild it, we will change the IP address. They are elastic by nature. They're not fixed like they are on-premise. And lastly, you saw the quote before from News Corp about doing places that are isolated from the internet. So with this build out, with our mission critical workload, this is actually an internal workload. It's a critical system. It doesn't need internet access. There is no internet gateway in this picture. The only thing joining your VPC to the rest of the world is the virtual private gateway, and that's joined to your customer on-premise network. So your clients from inside your network can access it. There is no internet access at all. What that does mean, though, is that you need to route the internet traffic back down through your on-premise. And you can do that over VPN and over Direct Connect. That means your IPSs, your IDSs, any of your type of security in your edge can be used to route that traffic out the internet. If you want, you can add the internet gateway into this workload, and you can add NAT in there so that private subnets can talk to the internet, but you don't have to. You can build yourself a small little cul-de-sac, which is just a data center extension. It doesn't have to be on the internet. It's private until you make it public. So, did we hit our objectives? Encrypted EBS. All of the blocks there that you put in Amazon, you can tick a box and you can make it encrypted with AES 256 encryption. Or you can run out one of the SafeNet Luna devices that the talk previously this was talking about. And you can have hardware supplied AES 256 where you manage the keys on your premise if you don't want to put the keys inside Amazon. We have an IPsec VPN, it's encrypted. And we have security groups, which are stateful firewalls to put around our instances. Available. So we have 2 availability zones. If you can have something that's stateless that you can put a load balancer in front of, or you have some kind of shared session state, then you can utilize those 2 AZs to help you keep your application available. You can use autoscale. You can set your autoscale to a group 1, which is setting of 111. That will basically keep rebuilding the box in place if it dies. It won't work if your application does need the same metadata. You need to use auto recovery for that. So we can replicate DBs between AZs. We can store our backups on S3. S3 has 11 nines of durability guarantee. From now until the heat death of the universe, we will try and store your data. And material impact. This is the thing that happens to your business if your mission critical workload goes wrong. So, no data loss, we're replicating it. We're replicating it to at least 3 physical locations because we're putting it on S3. We have encryption and we have auto healing on our core applications. CloudTrail. So the next thing you're going to say is, great, so I put my application in there, but I have no idea what's going on in the cloud. And I don't like that because I'm a security guy and I want to know what's going on in the cloud. So AWS CloudTrail is our audit log. When someone creates an instance, when they log into the console, when they create an encryption key inside our KMS key service, that is all recorded inside CloudTrail. What the time was, who the user was, and what call did they make. If you're using the console, it still shows up the same. The console calls the APIs in the background. If you've got developers using the SDKs, they call the API in the background. It shows up in CloudTrail so that you know who did what in your environment as an audit trail. CloudTrail is not turned on by default. So if you've got enterprise workloads running in your environment right now and no one has specifically turned CloudTrail on, then you actually have no visibility about what people are doing in your environment. So you need to rush out of here and go and turn it on. You need to turn it on in all region. It is region specific. And don't say, oh, well, I only deploy my stuff to Singapore, so I'll just turn it on here. Because if someone goes and starts something up and starts Bitcoin mining in your account because you've got a rogue person inside your organization in some other region, you're not going to get the CloudTrail log of when they actually created those instances, who it was, and what they did with them. So turn it on in all regions. We will send you a 0 log, basically saying there is no log data, and we will send you a CRC on it so that you can verify that no one's tampered with that log and deleted it. So you get worldwide visibility of who is doing what in your environment. For more audit capability, if you're using the Elastic Load Balancer, you can turn on logging. It will give you Apache-style Layer 7 logs. HTTP GET, this user agent, what actually happened. We talked about CloudTrail. We also have network traffic logging. It is Layer 4. It is NetFlow-style logging. It is not IP packet type inspection Layer 7 logging. But if you're used to NetFlow, you can turn on VPC flow logs. It will give you packet traces of, these are all the accepted packets, these are all the denied packets between the interfaces in your VPC. We give you them as actual logs that go to S3. You can then export them out into your own login infrastructure for your SIEM on-premise. We have AWS config. It will give you a snapshot in time of what's happening in your environment. If someone changes a security group, you can go back to the 5 days before and it will say on X date it looked like this, and on the previous date it looked like this, and this is the person who changed it. The other thing we allow you to do is ubiquitous encryption. Our KMS system is integrated with most of the services that you're going to use. S3, EBS, RDS, Redshift and Glacier all have tick box encryption for AES 256. We create you a master customer key and then you create data keys off of that key. Accesses to your encryption keys for unencrypting data, or decrypting data, accesses to delete or create those keys is all logged in CloudTrail if you turn it on. They are fully managed. How many of you have SSH access keys sitting on your laptop? When was the last time you rotated your privacy keys inside your actual own environment? When was the last time you backed them up in case you lost your critical data? We give you a fully managed system for managing those keys and it's highly available. And the last thing is it's integrated with IAM, which is our identity access. So you can give people specific roles of, I can access this key to decrypt this data, but I can't create, delete keys. I can't see who else has had access to those keys. So with role-based permission, you can isolate who does what with your keys. The thing about enterprises is you don't really have one environment. You have all these test environments and pre-prod environments and UAT environments and all types of other environments that we've imagined up over the years. Now the problem with that is if you need to build managed service infrastructure to put you into the cloud, managed AD, DNS, then you're going to have somewhere to store that and you don't want to recreate it in every VPC and every account. So what we allow you to do is you can create up to 20 VPCs in each account. You can create all the different environments as their own virtual private cloud. You can then use VPC peering to actually peer between all of those and your shared environment. You can then use a one-way peer into your audit environment to push all of your VPC flow logs, all of your CloudTrail logs, all of your access logs, and you can give the security team and your audit team only access to that audit. You can then use a VPN back into your on-premise to push it into your own SIEM workflows or your own login capabilities so that security has an isolated from the project teams and the run teams view of your environment. We can use the managed AD service that we have. We can create a trust with your AD. We can put a read replica in there so you use federated access. Use the customer gateway, the VPN and the VPW as we talked before, or you can use the direct connect. Don't go and create 1 million users inside your IAM and let everyone just access your cloud infrastructure. Federate your users. You're an enterprise. If that person leaves, are you going to actually remember to go into the ticket and remove all of their AWS access? If you use federated access, they can use roles. Roles are nice because they don't have keys that last forever, and they have session-based tokens. So the last thing I want to say on security is how much does it cost? All of the security features I've been talking about are $0. We make a conscious effort to make sure that you can secure your content without costing you money. The only thing that you pay for out of these is the log storage on S3. So in summary, why would you move your mission critical workloads? First of all, we give you the tools to secure your workload. You can encrypt all of your data with an on-premise key and push it into us and we'll never be able to see it. You have control of your content. We don't have access to your content. We manage the infrastructure. We give you lots of different ways to encrypt your data. And thirdly, you can operate the way you want. You don't have to go agile. You don't have to do CI/CD. You don't have to do DevOps and all of the cultural change. You can just extend your data center in, make yourself the cul-de-sac, play around with it, get comfortable with it before you do those things. You don't have to go 1 million miles ahead. Thank you.